One thing we've not mentioned so far are carbonates. All the examples we've looked at were clastic sediments. And you know from our third lectures that carbonates are somewhat different because they are biologically controlled, and especially for the tea factory, the tropical factory, they really depend on light penetration and they need to grow at sea level. So let's look in carbonates how we can apply the sequence stratigraphic model. And the first thing is to try to understand what we trace in carbonate system, because we've seen that for the clastic system, the trajectory of the shore face is a key indicator. But how about in carbonates? In carbonates, we actually trace the reef tract. The reef tract is our key indicator because it grows at sea level, and so it's an excellent marker of the position of base level. It's also important to realize that carbonates are cemented early, so they tend to be less remobilized during low stand. So compared to clastic system, they're better dipstick of the ocean. They're better tracer of what base level does. So if we look at an example here of a carbonate system, this is based on the Bahamas. In blue we have the reef, and you can see that during the HST, we also have progradation of the reef. So the HST is characterized by progradation up to that red surface, which is the unconformity. Now, when base level falls, what happens is the reef migrates from its position at the top here to a position close to the current sea level. And because the carbonates often have a relatively steep geometry, the implication is that at low stand you can only form a relatively narrow reef or a narrow carbonate system. So during low stand, carbonates tend to produce much less than during high stand. And the LST in carbonate is characterized by this fringing reef and of course by progradation, because just like in clastic system, we have normal regression happening in the LST. And then of course, the next thing that happens is base level is going to go back up, and you have the next reef that forms, and it starts with some retrogradation. We'll talk about why we have retrogradation in carbonates in a minute, and then progradation. So in many ways, carbonates are not that different from clastic, except that you don't trace the beach facies, you trace the reef tract. And early cementation of carbonates, which implies that they have a steep-sided geometry, forces them to have a relatively narrow low stand track. And that can be seen not just in the Bahamas, but also in other reef tracts. So here's an example from from Mallorca, and you can see exactly the same type of pattern here, where essentially we have a high stand reef followed by a low stand, narrower low stand reef, and then another high stand reef. So this is very characteristic for carbonate systems. But because carbonates are living organisms, let's look a little bit at their response, and let's try to understand the ecology of carbonate and how it impacts the sequence stratigraphic response of carbonates. So this is here an important diagram for your understanding of the sequence stratigraphic response of carbonates to base level change. So it's known as the law of sigmoid growth, and what it represents is the creation of an ecological niche, which is the dashed green line here. Now this niche in the context of carbonates represent shallow water tropical ocean. And the creation of the niche during sea level rise is relatively rapid because you have a shallow water carbonate system that is exposed and then reflooded, so you create a lot of shallow water tropical conditions which are ideal for carbonates. So on the vertical axis we have growth, on the horizontal axis of this diagram we have time. The creation of the niche is rapid, and of course the carbonates will want to colonize this new niche because it's ideal conditions for them to grow. But to do so, they need to reproduce. They need to essentially have offspring that then go and colonize this environment. And that's where the sigmoidal growth curve comes into play. Because the problem that any population, be it mice or carbonates, corals face, is that in order to colonize an environment, they need to reproduce. And that reproduction rate is proportional to the population size. And we know that during low stand, the population of carbonate corals is much lower because I've mentioned multiple times that they grow on a relatively restricted rim. So their rates of reproduction are going to be slow at first, which means that they're going to lag the creation of the niche. They're not going to be able to completely colonize that niche at first. And that's known as the startup phase. But once the population reach a critical mass, then they start to have a log growth. And so that's known as the log phase, and they essentially catch up with sea level. That's the catch-up phase of the carbonate systems. And then eventually the population is so large that they completely fill the niche and they are in what is known as the keep-up phase.